Yes, it's time.
Hello, everyone, and welcome to our robot reveal for this year. We are very excited to finally be able to show the robot to you. So let's get started. My name is Julian.
And I'm Caleb. So for today, we're talking about the program for today. Basically, we'll go through who we are. That is Team Pi, what we do, what we stand for. We'll give a small introduction to first and the FRC, how the games are and how everything goes. Talk about our sponsors. We are very grateful for them. We appreciate each and every one of you. We'll talk about the actual game, give like a bit of explanation of how the game goes, how it balances out, how people win, how you lose. Okay, actually, there are no losers, only people who learn, I guess, and some insight into what we actually like our thinking process. Some people say it's a bit funny, but I think those are the good moments, I guess. We will talk about the actual robot review that we've all been waiting for.
So after we've revealed the robot to you, we'll go a little bit more in depth about the robot itself. So we'll show the drivetrain, the intake, the storage and the loader, the turret, some electrical components, and last but not least, the software. And then we'll finish up with some of our sponsors, because without them we couldn't have done all this.
Nope, not possible. We are really grateful for them. So,
Uh, so who are, we are? We are Team Pi. We are comprised of some high school students from three different high schools: the Strabrecht College, Novalis College, and Eckhart College. And we have also some other members from the Fontes. There are also some members become mentors, and they help other people. They help other members get to know the team and to become a part of the team, so we can accomplish some great things and build some super cool robots. As you can see on the map, we are from very diverse places all around the world. And I think that's really a great point about our team, because all these different cultures really help us to achieve the best we can.
I'm Ghanaian, so right in the center of the world, beautiful city. It's in West Africa. As you can see, we are divided in such a way that out of the five livable continents, we have people from four of them. So yeah, I'm from Ghana, beautiful country. We have the best jollof rice, if you know what I'm talking about. Yeah, that's about the country and the people. And you're from
The Netherlands, so
yeah.
around here.
Oh, yeah. So as you can see, you have people from the US, from Africa, to major countries. Yeah, major countries. Ghana is a major country. We have people from Europe. That's a lot of people because that's where we are. And you have people from Asia, from the previous games and current games.
So as a team, we've participated in the previous 4 years in the first robotics competition, and we'll talk a little bit more about first.
And what they actually do. So about First is basically a non-profit STEM organization. Non-profit in the sense that almost everybody that works there is a volunteer. They organize science and technology events for young people to really be motivated and do more and to learn more. They host competitions for the past.
For the past like 29
Yeah,
years, they've hosted
29.
competitions. From the start, it was a small competition, but over the past around 30 years, they've really grown. There are more than 4,000 teams participating
Wow.
right now, so
Wow.
that's really
Wow.
a lot. It's incredible how much they've grown over the past few years.
It's amazing.
Yeah, it's wow.
And it keeps increasing
It's
also.
just more and more. So the main part, what they do is they hold robotics competitions for teams to build robots, compete with those robots, and learn and have fun with the robots while building them, and of course competing in the matches. So that's the most important thing for us as a team.
Yeah. I mean, for us personally, we participate in the first robotics competition, and it's a really a hassle for us. You know, it's like you meet people from electrical,
Yeah.
mechanical, high schoolers, and it's just a really dynamic environment. You
Yeah,
know,
exactly. You can learn a lot from all these different backgrounds,
yeah,
engineering backgrounds, and of course cultural backgrounds. Uh, So it's really extremely interesting to be a part of such a project. And personally, I'm really grateful that I have the opportunity to be a part of this team.
And learn from everyone. So specifically about the first robotics competition, um, we participated, I think, first time in 2017. So in 2017, we were just a rookie team, and amazingly, we won the rookie award. So applaud us for that. We won the rookie award, and I think since 2017, we're participating for 4 years now, 2017 to 2021. Yeah,
So yeah, as I've previously told you already a bit about, some of our members become mentors, and it's really useful to have some mentors in the team because they can really help the new students who are here in their first year get to grips with our project and with our team members. So I personally found it really useful that there was a mentor for me who could really guide me in the process of building the robot and just becoming a part of the team. And I think the entire process of our team really helps us to encourage new students to join.
yeah, and young people
Yeah,
in particular.
exactly. And then they get a greater understanding of how to build a robot, and they just learn a lot of things about technology. And we believe that's really amazing.
Yeah, it really helps to like go out and then really not learn just the engineering skills, but then get a chance to interact with people, learn from people, guide people, get some managerial skills also. That way, in the end, we are fully equipped for everything that is needed of us. And usually, that is before certain, pandemic, corona situation.
You might have heard of it.
You might have heard of it. We usually had like about 6 weeks to build, design, analyze, and program everything. But now, due to they gave us about 8 weeks,
Yeah,
7-ish.
yeah.
So it was still a hassle. I think we have a picture over here where you can see how it was before Corona. That's, I think, 2 years ago. But then right now,
Yeah, it's a little bit less, but we can still enjoy it, thankfully.
yeah, you still have some really fun moments. So yeah, that's really about it. 6 weeks is not an easy thing.
No, it's like actually it's a bit too few weeks to really complete the robot, but with a few late nights, it's always possible.
Yeah, a lot of late nights actually. Because I think I remember the first few weeks we had to come up with our game strategy and our game plan and really think about how everything is going to go, make a layout, use morphological charts and everything, and it was hard and interesting, I have to say.
Yeah, exactly. So now we'll show you a video, and it'll explain this year's game. So we hope you enjoy it and you get some useful information out of
You
it.
will enjoy it, trust me. Thank you.
Welcome to the 2020 First Robotics Competition and this year's game, Infinite Recharge. An incoming asteroid shower is aimed at First City. Using Alliance droids, planetary citizens collect and score power cells while traversing the trench run and boundaries to ensure maximum protection with an operational shield generator. Droids start on an initiation line and may be preloaded with up to 3 power cells. Droids operate autonomously during the first 15 seconds and attempt to score power cells into any of their 3 available power ports. While every power cell deposited adds equal charge to the shield generator, higher power ports earn more points. Drivers then control their droids for 2 minutes and 15 seconds of teleoperated time. Power cells are collected from one of the 5 chutes in the loading bay and then driven across the city to be scored in the low, outer, and inner ports. Droids must score the required number of power cells to activate sections of their shield generator, and then either rotate their control panel a specified number of times, or position it to a specific color. Near the end of the match, droids race to their rendezvous point to make their shield generator operational. Alliances are awarded bonus points for a level generator switch. The alliance that earns the most points wins the match. May the Force be with us all.
Wow, 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 wow. So that was the game explanation. Really well done. Let me stand a bit to the side. I think it's okay. Yeah. That was explanation. That was like really well done. I think you guys can now see like the balance between how everything like the game really touches on almost every physics component such that you really push yourself to do more and understand more and learn more on the way. So up next, we have somebody to explain and present to us what our game strategy was. We have our electrical slash mechanical slash software slash mentor slash designer something. Francis, just come on. Thank you very much.
Thank you. Thank you. Hello, viewers. So, as you said, my name is Francis Session, and I'm here to introduce or talk about the game strategy to you. So, first of all, the first competition, robotics games challenge, represent three main challenges, and the challenges are the first innovation challenge, and the game design challenge, and the infinite recharge at home. So, the first innovation challenge is basically about innovations, right? So it's like a team is assigned to actually identify real life problems and come up with or develop real life solutions, right? In an engineering approach. So let's say, for example, plastic waste management. So a team will probably, let's say, come up with an engineering approach to solve it. And the second game challenge is about actually designing a whole game plan from scratch, right from scratch. So it's basically about, let's say, a team will be assigned also to design a game, a game for the first robotics competition, right? So if, let's say, they can probably set up a whole game plan from scratch, which basically will comply to all the game rules and regulations as well. And the third challenge is the infinite recharge at home, right? So the infinite recharge at home is basically about also designing robots from scratch and competing for awards, and also competing in skills competitions, which I'm going to talk about in a few minutes' time. Um, and as Team Pi, we were assigned and we chose to participate in the Infinite Recharge at home. This was basically our choice because we wanted to start actually building from scratch and have this feel of engineering and the experience of it. So in our choice of field, which is the Infinite Recharge at home, there we could get the opportunity to compete in awards like the Judge Awards and also some skills competitions. And here you can see on the screen some skills competition and Judge Awards as well. So for the Judge Award, we have several awards based on your based on your choice of challenge. Then you get the awards, and also the skills competition, which we undertook. Some of them are the hyperdrive challenge, the interstellar challenge, and also the powerport challenge, right? So the hyperdrive challenge is basically about emulating the driving skills of your robots, right? So it's basically about moving the robot in a specific part to demonstrate it and send the videos to Fresh Robotics to compete or access it. And the Interstellar Challenge is about emulating the shooting abilities of your robots, right? So you can see on the screen that we have various zones in which you can actually display your shooting skills. So that's for the Interstellar Game Challenge. And also for the PowerPoint challenge, it's also about emulating your shooting skills, but in a teleported manner, which you can also use to shoot your power cells. And the shooting power cells here, in a sense, means like the balls that we actually shoot for the competition when the competition goes on, actually. So up to this point, I'm going to introduce a very funny video uh, to you guys also, and also uh, I'm going to introduce my friend who's going to, my colleague here who's going to continue with the video.
So thank you very much, Francis. It was a great explanation. So now we'll move on to the next part, which is some funny videos of our building season. We really believe this video captures some of the best moments we've had during this building season. So we really want to share it with you. So I'll recommend you to have fun, which should be not a problem. En allemaal dankzij mij, hè?
2 ballen tegelijk. What? Dat is los? Ja, houdt u wel. Dat deed je net. Hier.
Oh no. So those were some of our most funny moments this building season. But now it's finally time to show you our robot. We are really excited to finally show you this. So I won't keep you waiting. We'll show it in 3, 2, 1. And there it is. We are really proud of the robot we've built this year. And as I said, we are really happy we can finally show it to you. So take a good look. It looks really beautiful, at least I believe. We've put a lot of work in it, and we're really satisfied with the result. We believe it's one of our most successful robots we've built. So yeah, we're really proud of what we've achieved, even though this year was of course hard. We believe we've really put in a lot of effort, and the robot has turned out beautiful. So as a team, we can be very content and look back on this year with a lot of pride. So it's amazing. So Caleb, oh, there's a little demo coming now, I believe.
As you can see, we have an omnidirectional approach to it. Yep, it's amazing because it looks easy, but it's not as easy as it looks. So it can turn on its axis as it's doing right now. We put the power to like very low for safety reasons and to make sure that everything goes exactly as we expect. So it can rotate on its axis, move omnidirectional in all directions. Um, yes, as you can see, all the wheels are facing the right, and then you change, all the wheels go forward. This may seem simple, but even the normal cars that we have are not omnidirectional. I should tell you how complex this is. It involves really advanced maths. Advanced maths. Next, we'll show how the turret works, the loader and the intake system. We have some balls coming in. Can you roll the balls, please? And the turret works. It's in theory a 360 degrees turret, but because of the game specifications, we decided to make it move only a range of, I think, 100 degrees, 120 degrees, actually, 120 degrees. We have the balls rolling in. Thank you. We have some balls, and it takes it in automatically. It goes in. The loader system, yep. The intake closes. The loader loads it into the turret. We are adjusting the outtake for it to make sure it's at optimum range. Loader should load it. And it's powerful, really powerful. Really, really powerful. We have a few more balls to show the aiming. We have our own setup here. It's part of the Infinite Home Challenge. More balls rolling. Oh, yeah, these are the perks of engineering. Sometimes it works, sometimes it still works. Amazing. So, because of time reasons, we are going to show everything else at the end to build up the suspense. For now, we're going to continue with the presentation and show you guys a few more of how this really came about. Yeah, so these are our sponsors, our amazing sponsors. As you can see, we have some colleges. We have Elobao, which gives us ultrasonic sensors, Tinytronics, which provides us with all the electronic components, the small electronic components that we need. We have Fontes in the middle, where I go to school. It helps us guide the students, provides us with students to actually build the robots. We have Rosen Industries. They did the metal works for us. We have RS, SMC. Yep, we have SMC. People, there are so many colleges. Some of them are in Dutch, and my Dutch is not so good yet, so pardon my French. We have, yeah, people right here. We have, yeah, these are in conclusion our sponsors. Not all of them, but majority of them. Up next, we will be having a deep dive into our drivetrain and how it works because it's really different. We have here Martine to give us a brief explanation. Martine, software slash everything designer.
silences. Okay, so I'm going to talk a little bit more in detail about the robots and in specific parts about the drivetrain. So for this year, we wanted to create a more modular system for the drivetrain so we can use it for multiple times. I can show the robot here aside for me. A little bit down. Okay, so as you can see here, this is a robot. The drivetrain is the whole lower part of the robot where everything is built up from. Because of the modularity, we wanted to create something to easily build on and use it to create new functions. Like now we have a turret, but it should also be possible to put something else on it. The modular has 4 swerve modules that you can see here. These modules turn 360 degrees with one motor and drive forward or backwards with the other motor. So this gives us a full 2D rotational space of the motor. So we can drive really advanced patterns, be quick, and don't have too much delay in our movements, and make the robot more competitive. Volgende slide. Nee, slide. Okay, so here you see the multiple parts of the robot. So we designed it so that it's lightweight, and as extra feature, we built it so that there are holes in all the tubes in the robot for cable management. So this makes it very easy for us to create new designs with the drivetrain, adjusted to our specifications for this season and for later season. As you can see here, we have a mesh plate. This goes into the robot at the bottom, and we can attach different hardware to it to make it really easy to switch parts around in the future. So now Marius is going to talk a little bit more about the intake of the system.
Yes, thank you, Martijn. Am I in the sheet? Yeah, thank you. This year for the intake system, we've gone for a scoop design. This scoop is extendable. It can extend with the 2 pneumatic cylinders on the sides. Oh, yes, thank you. This is very important for us because we want to extend the scoop when we want to pick up the balls, and as soon as we're done, we want to retract it again so it can't get damaged while it's driving around. We have calculated exactly how fast the wheels need to spin for the balls to go into the storage. And also we have calculated what's the angle and the length of these sides arms need to be for it to fold out at the perfect length. Also, the waste air from the pneumatics is routed towards the swerve modules for air cooling. As soon as the balls have entered the storage, they can be processed by the loader. And Esmeralda will talk a little bit more about that.
Thank you. Yeah. So the loading mechanism works as follows. So there's some louder. So sorry. Yeah. So we have some wheels inside the loading mechanism over here that make it possible for the wheel to be compressed enough to then be loaded inside the turret. The turret here was next. Okay. Yeah. So yeah, as maybe you can see, we have 2 wheels here that prevent the balls to get stuck inside the storage when we want to load them into the turret. And when the wheels are activated, the ball is pushed inside this small tunnel that then loads the ball into the turret. Yeah, the turret is a further development of design that we made for a previous semester. Yeah, it basically consists of wheels that compress the ball against this wall here. And this compression allows the ball to be shot outside of the turret at very high speeds and far distances. And in order to be able to aim at different heights, we have this extension here. And by just adjusting how far it goes, we can aim different heights. Um, yeah, that's it.
So thank you for that explanation. That was really great. Now we'll move on to the second part of our robot, and we'll start with electrical. So I'll introduce Francis again, and he will talk about the electrical components of this year's robot.
Oh, welcome. Here we go again. Here we go again. So, Francis, I'm gonna briefly talk about the electrical aspect of our robot. And first of all, as you can see on the screen, we have a general overview of the electrical schematic that was made by our electrical team for the robot. And you can also see we have our PDP on the left, which basically stands for a power distribution panel. And this power distribution panel is basically uh, a component that draws power from a 12 volt DC battery to all the various components respectively. This is mainly done through auto resetting of some functions and distributes power to other components. And we have also our NI RoboRio. This RoboRio is basically termed as the main brain of our robot because this serves as the brain because it's actually being programmed by our software teams by actually setting some inputs and outputs, which does all the processing and communication and programming of our robots, our nicely built robots, as you can see over here. And also we have our Open Mesh OM5P AN. This component is basically also called the radio, and this is mainly for the wireless communication of the robot. When I mean wireless communication, it basically communicates through it's a source of communication wirelessly through the robot and the RPC, so that we can actually wirelessly control our robot. So I'm going to move on to our next presenter, Ma- Caleb, which he is going to introduce our next presenter.
Yep. Thank you. As you can see, the electrical parts, we were the electrical guys. If you haven't noticed, it was really interesting working on electrical because it was quite a hectic thing to do because you have to like really learn from the mechanical guys, team up with the software guys, make a connection between the two to make sure that if this guy says he needs a sensor, we have enough cables and enough room with the mechanical to make sure the wires can really go through. We even have like infrared sensors, which had to be like in the front, but then the microcontroller is at the back, and you have to be like really smart about it. But that's just about electrical. We did all this in 6 weeks. 6 weeks may seem like really small or really big, but it was interesting. That's the word, interesting. Up next, we have Martin again to talk about the software. I was also on the software team actually, but yeah.
Thank you, Caleb. So this year for software, we wanted to take a different approach because we had a more controlled environment. We wanted to make a more complex robot, more specific to the vision part. So for our vision, we use this Intel sensor that can also see depth and see the images. So we use machine learning to train a protocol to detect objects like you can see here. We also wanted to create a more modular code because our drivetrain was modular. We also wanted to have the codes be used for next generations, for next drivetrains, make it easy swappable between the motors and all that sort of stuff. So I was talking about a self-learning algorithm for the robots. This means that we used machine learning to teach the robots how to detect the image. And this was done by creating many pictures of the target and then saying to a teacher bot to teach our robot how to detect it, what are the features of this target, and how it's supposed to see it. With this, we had a huge advantage in detecting the target, knowing its position, and knowing its depth with the use of the Intel camera that I talked before. This gives us a high accuracy and repeatability into the process. So as you can see here, you see like the little algorithm that we use. So we have multiple inputs of the robot, and together they combine an output of the trajectory and the velocity of the robot to be very precise and accurate. Next, I'm going to talk about the swerve drive. Because the swerve drive is something new for us, we had to build it from the ground up. We started with the kinematics of the robot. And with these kinematics, we got the idea how the swerve behaved when different velocities, angles were applied. After we got a sense of what to do, we came to the conclusion that every module has its own speed, angle, power. So we had multiple codes or multiple calculations for the same modules, but every module behaved differently. In the end, this was complicated, but created a nice implementation of the driving robot you see now. Here are our sponsors again.
So we really want to take a moment to thank our sponsors because without them we couldn't support a team like this. We can't create all the parts by ourselves, and we really rely on sponsors to do the work we do here and to create these incredible robots. So it's really important that people sponsor us, and that's why we really want to thank all the sponsors you can see here on the screen. We really want to show them our gratitude. Without them, this would never be possible for us, and we couldn't do these great projects. And all the learning we do here, we really rely on our sponsors. So we can't thank them enough, basically. So from all of our team members, Caleb agrees as well, I believe. You are amazing. Thank you very much.
Yeah, the team members. We really appreciate the team members because yes, the sponsors helped us get the things, but without the team members, it wouldn't have been so good. It would not have been so good. So that's for the sponsors. We have up next. Drum roll, please. We have up next. Suspense, please. We have up next. Questions and answers. Let's go. Questions and answers. So in the live chat, you can ask your questions. We have a limited time. You can ask your questions. We'll do as much as possible to answer it. You can ask questions about our game plan, how it went, strategy. We can give you insight into how we did it. Anything. Just let's go. Any questions, guys? I'm here for you. Okay, not necessarily here for you, but you know what I mean. If you have any interesting questions, I would love to answer them. Keyword is interesting. If you know you're an engineering major, please don't ask any difficult questions. Thank you very much. Any questions? What was the hardest part of building this robot? Ooh, I think this question, most of us can answer it, but some people had it the hardest. They might want to answer. That people is me. So the hardest part of it was what was really integrating into like working with everybody because we are all of like really diverse cultures, really diverse way of timing, really diverse way of doing things. So it came about with integrating the whole system because you have mechanical, software, and electrical, right? And even in software, I was part of software. We had to how do I put this? We have to make things modular. And by modular, we should be able to transfer the program to other robots easily. And we have about 3 robots. So that was really the challenge because one way of programming, right? You can just write everything like and you have everything down and it works perfectly. But here's a case where we have to make sure everybody can understand. You have to comment your code. If you know what I'm talking about, you have to comment your code, and then it goes about the vision processing. That part was hard because you really have to learn things that the university doesn't teach you. The university doesn't talk about it. We had to do what do we call it? Can somebody help me? What do we call it? The extra managerial roles. What do you call it? Yeah, we had committees inside also. So we are not just a team of basic engineers, but we are a team that is supposed to really reach out and learn soft skills like managerial and part of PR. If you haven't realized, public relations. Yeah, Esmeralda, I see you. I see you. Esmeralda and I. So, is there any other question? Martin. Yes. He's going to answer it. He's our technical guy.
So the vision system is very accurate. The question was how accurate is the vision system? So when the target gets into the field of view of the vision system, this the Intel sensor, the camera can immediately say how accurate it is. It knows its exact X and Y position and its depth, so it's pretty accurate. But due to problems with our NVIDIA Jetson or microcontroller taking too much power at the moment, we can't use it for this demo, but will try it for the next one. Okay, so the question was, did we develop our swerve drive from scratch? And the answer is yes. We designed the whole system ourselves and programmed everything from scratch because we wanted to be modular and wanted to be other than other teams. Caleb again?
Just stay here. Wait, can we go to the other question? Somebody's asking what kind of machine learning algorithms did we use? I think that guy is an engineering major. I really like the question. Could you help us answer it? Just to shame him or something. He's my brother, so.
Okay, so we used machine learning and we used an open source vision system that is called RoboFlow. RoboFlow is a really easy to use environment to create your own vision systems and machine learning projects. So that's what we use to create the advanced algorithm to know what's the target, and we can expand it with other items in the future if we want.
We have another question. Thank you very much, Martin. We have a question. What was the favorite thing about the robots? You can help us answer it?
I can try.
Yeah, just tell us your favorite thing. We'll have two people answer it. So you tell us and then another volunteer.
So what was the question again?
Your favorite.
What? So the question is, what was my favorite thing about building this year's robot? And for me personally, it was when we put together all the modules and the final robot came together. And we could see everything we had previously seen in the design process. We could see it in real life. And for me personally, that was a great moment because you can see all the hours you put in come to life, and you can see your own product realized. So now Francis has another part of the answer of this question. So here you go.
Oh yeah, thank you. The question was, what was the most beautiful thing about your project, right? And I can see from the project when I look at the robots, it's like the beauty of it. It's so beautiful and modular in a sense that you can just watch it and you will just be proud of it. So it's just so beautiful in the extent that you be just much proud of it. Yeah. So Caleb, there's another question. Yeah.
So we have another question for Martin. He wasn't the only person on the team, just to clarify.
Okay, so the question is, how long did it take to develop the Swerve drive? So the Swerve drive is already 2 years in development in Team Pi, but because this was a special season, we wanted to continue it with this season and use this season as an advantage in creating a swerve drive and using it for the first time as our team. Okay, so if I do it again, what would I like to change about the robot? That's a tough one. I don't know. Maybe Caleb can maybe answer it.
What would I change about the robot? Maybe nothing because it's beautiful. But if I really, really had to choose, I would say it's too metallic for my liking. It's just the beauty because the system works perfectly. I just think we could have, included like some carbon fibers or something if our sponsors would sponsor us to give it a really classy look or something.
Okay, nice.
Anything you'd like to change?
Yeah, maybe in the end I would change some of the turret's cable management systems and maybe use some PCBs to make it able to turn 360 degrees and use the full advantage of the robot. So, are there any more questions?
Are there any other questions? Okay, so I think we don't have any other questions. Because of time, we get to the most exciting part. Oh, we have a question. Okay.
So the question was, how was it work in the team as a high school student? I am one of the high school students, and for me personally, it was a great experience because all these parts in a robot, it's really professional, and it's something you don't experience in a high school. So it was a really big step for me, and I personally really enjoyed it because you can really create some things that you don't have the possibility in a high school. So for me, it opened a lot of doors, and it really showed me what engineering is like. So that's something I really enjoyed about it. Do we have another question, or was this everything? Oh, well, Caleb can answer a new question.
Oh, my brother has a question. Can somebody read a question to me, please? The total weight of the robot. Well, the robot was quite light but heavy at the same time, if you get what I mean. Like it's in such a way that you cannot carry it easily, but it's super light. I know you understand me. So the weight of the robot is around ranging from about 30 to 50 to 100. I don't know. I can't tell. Thank you so much for the question, by the way. What was what? The materials. It's made of matter. Do we have to answer all the questions? Can we ignore some people? Okay, fine. Let's be nice. What was the last question? Yeah. That question I would love to answer due to time. Should I answer it? No. So due to time, we're just going to show the robot because it's sitting there looking all beautiful and amazing and classy. So we're just going to show the robot quick demonstration, shooting mechanism, and all the works. Thank you very much. Yep, it's time. It's time. It's time for us to demonstrate the robot. So this is what you're going to do, right? You're going to drive the robot to the center, pick the 3 balls, drive back, and shoot. Start placing your bets. Let's see how many goals we can score. Ready? Set? Go. Oh, we have on the controller our amazing driver, Milan. Are you ready? These are the perks of engineering, you know? Sometimes it works easily, it connects. We have a question? Do we have a question? Yes, I'm listening. Oh, how is it to change the battery? Yeah, so that was actually one of the things that we had to really look at, because the previous years the people messed up a bit with the battery. So we made it easy to remove and insert the battery right at this point. You just take it out, remove, and put it in. That was really easy question. Thank you for that question. Milan, are you ready? Yes. Any other question? Another question? Oh no, it's not stuck at the bottom again. Okay, so we had to make this ourselves. It was part of the Infinite Challenge Home Edition. We had to make this and sort of set up our own, make our own setup according to the rules and regulations of the game. One of the yeah, one of the requirements was that we line up balls, we pick them up, and we score. So not only about how fast your robot is or how slow it can be, or it's more about efficiency. How efficient is your robot? How interesting is it? The design process that you undertook to design the robot and to make everything work perfectly. It's really not just about the product. It's about the process on how you get there. It's quite challenging and interesting. I really wish next year. Yeah, and if you guys have more questions, you can ask them. Whilst our brilliant engineers are working on it, I think we have a few, not setbacks, not problems, a few things we must learn because we keep learning and we are barely students. Okay, all of us are students. Imagine this, right? Being students in this Corona era, like this pandemic season, we have to build such a robot. Did you know that here in the Netherlands, I know everybody's from like all over the world. Here in the Netherlands, we have a lockdown and a curfew. So even late nights were a difficult thing to do. And we have managed to come up with something as beautiful as this. We are happy. We are proud. We can put our hands on our chest and say that we made it. We did it. Julian, how was your experience? Like at the beginning, the middle, and the end. How was your experience?
So of course, in the beginning, it's a little bit getting used to the team and getting used to the environment here. But with some few weeks under the belt, you get used to the situation and you get to know all the team members. And of course, you get a little more experience, and everything settles. So for me, it was a great learning curve, and at the end, I really believe we've become a team, and that everyone has become a part of it, and everyone can give an input, and we really appreciate everyone in the team. I believe our robot is ready to do a demo. So let's start. So here it goes. There it drives towards the balls. It puts down the intake system, and now it will pick up the balls. So there goes the first one, and then it moves to the 2 remaining balls. So it successfully picks those up as well. Now it retracts the intake system and it makes its way towards the goal. So the turret is already positioning itself, and when the robot is positioned right now, the turret will start to aim more precisely. Now the balls are starting to get shot. 2 out of 3. 2 out of 3 is not a bad score. So,
I want you guys to do something for me, right? Before we get to the next point where we score the next set of goals, I want you guys to guess how many balls we're going to score. Just humor me. Let's see how much faith you guys have in us, right? I can place a bet, not really betting, but I can tell you we're going to score all three. Who's there to challenge me? Let's go. We are going to score all three balls, not two of them, three this time. Any challenger, just write in the comments how many balls you think we will score. Yeah? Let's go. Okay, so now we are going. We're going to start. So another challenge is that I'm going to pick one ball and then two at the same time. And we are moving slowly on purpose. We don't want you guys to miss the whole show. Let's go. The first ball is in. We have three. Everybody say 3 out of 3. Thank you guys. Thank you guys. Yep. It's engineering. It happens. Yeah. Let's go. All 3. Yes, thank you. Can I get a phone? Okay. From Kirk, we have 3 out of 3. From Wilco, we have all balls. Thank you. Stefan, 2. Okay, we'll see. I mean, it should count. It should count as a 3 out of 3 because it was on the edge, you know. We scored 1, but it should count because. Fine. How about this? If the team agrees, right? We are going to go another round. Yeah. Does the team agree? Okay, another round. Let's arrange the balls. Can you clean your room like this? Well, it's part of our aim. It's part of our aim to make it like almost autonomous. That's why we have so many complex algorithms. Yes, you can see it again. Okay, place your bets. Going once. Place your bets. Let's go. Amazing! Woo! Amazing! Who would have thought? And this was built in 7 weeks, approximate. 7 weeks we built this. You have an amazing team right here. You guys want another show? Can we afford another show? Please, pretty please, another show, please. Another show of shooting or fancy driving. Oh, the balls are at the back. So that was a 3 out of 3. 3 out of 3.
So now we'll do it one final time with all 5 balls. So this is really a challenge. You can place some new guesses in the comments. Will you score all 5? Did we build a robot which can do this? We'll find out in a few minutes. So here we go. So now it starts picking up the balls again.
Oh, they can see.
We have some bets.
Yeah. So 3 balls in. We will shoot at 3. Okay, we loaded 1 ball into it to make more space. And we have 5 balls inside. 5 balls, ladies and gentlemen. 5 balls. Hold up. Give me a second. Place your bets. Let's go. So, I go for 6 out of 5. I don't know about you guys. 6 out of 5. Let's see. 3, Wait, hold up. Let's just build up the suspense a bit. How many balls do you guys think we can score? I'm waiting for the comments. We have from Yon, 6 out of 5. Stefan, okay, Stefan, okay, we'll see, we'll see. Kweku says 5 out of 5. Anyone else? Our beautiful audience. Okay, we have believers in the building. Believers in the building. Okay, let's go. Are you guys ready? Are you guys ready? We have the LeBrons and the Lewis Hamiltons. 3, 2, 1. It's a goal! It's a goal! Thank you, thank you. Oh, shit. And that is it for today. Thank you guys so much. And we would like to thank the sponsors again for helping us make this dream a reality. Thank you guys so much. And I would like to invite the team, guys. We just want you guys to see you. I want everybody to see you. The team, Milan. Come on. I want everybody to see you. Can we see us, Julian? Can you come? And just take note. This is not the whole team. This is what a pandemic does to us because most of us are working part time. We have family meetings, so this is half the team. The whole guys, hurry up. Let's show the whole team. Thank you guys so much. We really did try our best. In a second, you will see the whole team. Again, not everyone is here. We have a few people missing because of Corona, obviously. In 3, 2, 1. Thank you guys so much. This is the full team. Okay. Can you guys give me a yay? Give me a yay. That's what I thought. So thank you guys so much. We want to thank our sponsors. Thank you so much for the chance given us, helping us make this a reality, actually. Thank Anita, especially the CEO, the toughest so far. We have Ivan behind the camera, the COO or CTO or COC something. We have the CIO. Nick, please. Thank you so much, Nick, thank you so much. He really helped us a lot. We have, yes, Ivan and Anita. You guys stand in the middle for us. Woo! Thank you guys so much. Thank you so much. Yeah, she gets shy a lot. And she can talk. Don't mind her height. She can really nag. Okay. We have Peter, our tutor from Fontes. Yeah, he grades us. Thank you so much. We have the software team. Thank you guys. 1, 2, 3, 4, 5. Yeah. We have the mechanical team. Boo. Yeah, we have the mechanical team. I love you guys from the bottom of my heart. Yeah, so thank you guys so much. We have Julian over here. You guys have already met him. Thank you so much. Just note, he's not the only high schooler amongst us. We have a few others, but because of certain reasons and corona measures and the whole shebang, he wasn't able to be here. I think I've introduced everyone, right? Yeah, I think we have a few people missing, a few vital members. Actually, all of us are vital members. Maybe not Renz, but all of us are vital members. Thank you, Renz. Thank you so much. And that is it for today. Thank you all so much. Again, we thank our sponsors. I am Caleb Akwabwache from Ghana with the best jollof and a beautiful country. Yes, I'm here to sell my country to you. It's in West Africa. You should visit it. You have the best tourist attraction, the best places, and food and everything else. And a beautiful country, Netherlands, where it rains all the time and snows and sun shines in a matter of 3 hours. It's weird. Ugh. Okay. Thank you guys. Thank you so much.